right, this is an explanation of limiting reactants. This is the example that we went through in your notes, but if you need a verbal explanation, this is a good reminder. So remember, with limiting reactants, you will be given the amounts of both reactants in the problem, so you actually have two numbers instead of one. It doesn't matter which one you start with. I usually start with the first one just because it's first, but it really doesn't matter. Another thing to remember is when you are trying to figure out the limiting reactant is going to be one of the chemicals that is listed to the left of the arrow. So the limiting reactant is going to be a chemical, a substance, not necessarily, or it's not going to be a number, even though you use a number to figure out which one is the limiting reactant. All right, so I'm going to, in your calculation, you're going to compare the two reactants. So if I start with 80 grams of copper, I would then figure out, if I start with 80 grams of copper, how many grams of sulfur am I going to need to react fully with that 80 grams of copper? So when you're doing a limiting reactant problem, you compare the two reactants. So first you have to go from grams to moles. So you would use the molar mass of copper from the periodic table, which is 63.55 grams of copper for every 1 mole of copper. So your first step is to change grams to moles. Now we have to compare the two reactants, so we're going to compare the mole ratio. So from our balanced equation, for every 2 moles of copper, I need 1 mole of sulfur. So that comes again from your balanced equation. That cancels our moles of copper out. And now we can go from moles of sulfur to grams of sulfur. And grams of sulfur, again, is going to come from the periodic table, which is 32.07 grams of sulfur per 1 mole. So then when you have your calculation, you multiply all the numbers across the top, and you divide by all the numbers along the bottom. Whoops. Sorry, one of my numbers didn't register. So we end up with 20.186. So with 3 sig figs, we'd end up with 20.2 grams of sulfur. So this is how much sulfur is needed for all 80 grams of copper to react. So then, for step 2, you compare how much you need, which is here, to how much you have, which is up here in the problem. So for all the copper to react, we need 20.2 grams of sulfur. We have 25 grams of sulfur. So we have extra sulfur. So sulfur we have extra of, which means that that is our excess reactant. So we're going to have sulfur left over. So because sulfur was our excess reactant, by default, we know that copper is going to be our limiting reactant. So copper would be our limiting reactant in this case. Copper is going to run out first, and it's going to limit how much product we are able to make. So when you are finding the theoretical yield, you have to start with your limiting reactant because that is going to, again, limit the amount of product that you get. So when you start with your limiting reactant, you're actually going to start with however much of the limiting reactant is given in the problem. So we're going to start with 80 grams of copper, again, only because that is our limiting reactant. But now we're going to figure out, since copper runs out first, how many grams of product are we able to get out of this reaction? So theoretical yield means what's produced, so then you want to end with your product. So we're going to use the same process. We're going to go from grams of copper to grams of copper sulfide. So to convert grams to moles, you would again use the molar mass from the periodic table. To convert grams of copper to moles of copper. Then we're going to use our mole ratio from the balanced equation. So we know that 2 moles of copper will react to produce 1 mole of Cu2S. And now we can convert moles of Cu2S to grams. So in 1 mole of Cu2S, if we add up the molar mass from the periodic table, we get 159.17 grams of Cu2S in 1 mole. So again, you multiply the numbers across the top, divide by the numbers along the bottom, and we end up with 100.185. So we would have 3 sig figs, so we're going to do 100 with a decimal, grams of Cu2S. So if everything goes perfect in the reaction, this number, the 100 grams of copper sulfide, that is your theoretical yield, which means that is the maximum amount of product that can be produced because copper will run out first. Hopefully this example helped. Of course, let me know what questions you have.